Well, hi, good morning. Welcome to my shop here. It's the 28th of June today, and I'm on my third day, I think, of trying to investigate this IF transformer here, which has been really a pretty unproductive time for me anyway. I'm really not concluded anything about this, so I'm going to start today. I've already done a little bit here actually, contrary to my usual practice of doing nothing till the camera's on. I have already fiddled with this a little bit. So I want to review why I'm doing this. It's for my own sake too, because sometimes you forget, time goes by, just exactly why you're doing something anyway. You get kind of involved in it. So the reason I've got this out on my bench is because when it was in the radio and I went to do the initial IF alignment, when I got to this transformer, I found the top slug would move the tuning. The lower slug appeared to have no effect on anything. That's what got this. That's the first observation, and that has been kind of continuously true the whole time I've been working on this thing, until the very end of the last video, when the lower slug appeared to be able to move the resonant point of this coil around for the first time. That occurred with this great big crazy clumsy decade box resistor in there. That's what these big clip leads are here. That's for this one. Just padding down the output from the sweep generator, which is running up here. Sweep generator. And that's a lot of padding when you've got megohms of padding, or half a megohm of padding in here. That seemed to allow both primary and secondary peak to be visible simultaneously, and I seemed to be able to line them up. The thing is, there's no capacitor in here. Well, there's a capacitor sitting here. It's not connected. The original one's not connected. And no external capacitor or added capacitor. Nothing. Except of course this box and whatever it might amount to. This is a resistance capacitance box. It's kind of cool, resistor, capacitor, series combination, parallel combination. It's kind of a neat box. But I just have it set on resistor here. It's just a resistor. But it's going to have some capacitance. Let's talk about that for a minute. The capacitor in here, according to the schematic, is 56. I think I saw a 5 on it. So 56 picofarad capacitor sitting here. Test leads and things like that. The lead wires themselves, 2, 3, 4 picofarads. So these wires might have 1 picofarad of capacitance, just the way they are. Until you get up around 50, well, maybe up around 20, it's not going to make a lot of difference if there's a 56 sitting here. By the way, the 56 measured at 47 in one of my tests, a little bit low. So apparently what it looks like is no additional capacitance except maybe a little stray. Well, it might be 10 picofarads, 15, I don't really know. Seemed to be the amount of capacitance needed to get this guy to resonate in the range we need it to resonate in. Why would that be? I don't know yet. I don't know. I don't know if I'll ever know. So I ended the last video. My decision was I'm going to put this back in the radio and carry on because I was just frustrated. But I've heeded the sage advice of a friend of mine who has strongly suggested that what's really happening here is I've got my signal generator firing up the primary, and then I'm kind of listening to it or looking at it on the scope from the secondary. So the secondary is essentially free, can I put it that way? It has a high impedance connection from the scope. Make sure it's high impedance here. So it's working pretty much the same way it would in the radio. On the other hand, the primary, which I was energizing, is hooked up to a low impedance supply. Now exactly what that would do to this, I don't know, but low impedance means strong. So to raise the impedance of the input, I simply stuck this resistor in here. And lo and behold, I tried this with a regular resistor, it didn't seem to do much. Lo and behold, that seemed to help. So I've heeded the suggestions of my sage friend, my sage suggestions of my wise friend, and I've reversed everything. So now the primary coil is being energized by the signal generator. Other way around. The secondary coil is being energized by the signal generator. I can see the wire right here. Right from here, right to there. So that is now influencing this coil. This coil is only connected to the oscilloscope, which is what you've been looking at in the top right hand, the picture the whole time. So I have this basically reversed the way it was. The theory is the way it was, driving the primary, watching the secondary. Of course you can see the influence of this. Of course you can. Look, you can see the influence of it now. So if you think you know where I'm going already. But moving the slug in the coil that's being energized by the signal generator won't do anything. So I reversed it. So now it should be the other way around. Doing the slug in here, we should see a nice resonant point move around, just like we saw before. The other way. And this guy should have no influence anymore, if all is exactly as it was, only reversed. Does that all make sense? In the meantime, I have spread out my sweep. It's sweeping from 300 kilohertz to 600 kilohertz. So the first thing that you could say, looking at that, because it's 300 here and 600 there, is that there ain't much of a peak on this thing. And it's down in this range somewhere. It's around 400. 300, 400, 500, 600, 900. Something like that. It's way off. I mean, you can barely see it too. So now we're going to make some variations in here and see what happens. So watching the scope now, we'll fool around with the secondary coil, which is actually receiving the signal generator signal. And if you're asking, Jim, do you really know what you're doing? I know exactly what I'm doing, but the result is not at all what I expect. That's where this thing has been at. Do I know exactly what I'm doing? Well, I believe so. Isn't that good enough? So watch, as I pull this slug out, look at what is happening. A funny little bump has happened here. Is that visible? Yes, it is visible. Funny little bump here, and it's widening out right at the end. So it's... What does that tell you? I don't know what that tells you. Pull the slug right out. It is out for all intents and purposes. I'll shove it back in. It's just going in the coil now. And it's coming out the other side of the coil, I think. Yeah. So I've just gone right through it. The point where it's going to start to influence the wrong coil. So what do you make of that funny shape there? Look at that. This didn't get me anywhere. So I still have this resistor. Let's fiddle with it. Oh, isn't that great? That looks a lot better. So I'm raising the resistance. Or let's just see now. It's really gigantic here, and this looks like a series. This looks more like a series resonant circuit. The resonant point here. What am I doing? Just flipping switches and watching the funny pictures go. Wow. Less sensitive. So this is like 300 kilohertz here. The middle is above 450. The resonant point is like a mile away. Okay, let's see if we can move that. What's going on? Wait, come on. How far can we get it? Look at that. Okay, well, that's what the slug rate out. So, somebody help me dearly. Slug out, capacitor out, bingo, she works. Okay, leaving this slug out. This is not what I wanted to be doing here again today. I really wanted to be just nailing this thing down. Use this. Getting bigger. Getting bigger and bigger. Bigger. Whoops. Oh, it didn't fall in, but how do you like that? So we're heading for it with this slug maxed out. This is crazy stuff here. This is just crazy stuff here. What is going on? Put that back in. So this just appears to be resonating completely the wrong place. Okay, so let's put that into sort of a typical spot, and this one would be typically about here. Have I done something wrong with the sweep generator? So this sweep generator, when it's sweeping, it reports roughly the middle of the sweep. I don't know if you can see the numbers or not. 451, 450, 451, 452. So it's kind of catching the middle of the sweep. So you can kind of tell that at least I've got it balanced around 450. 450 being pretty much in the middle here. Let's check. Start frequency is 304 kilohertz, and the stop frequency 601. So it's 300 to 600. With I put 450 in the middle. Yes, it does. Reporting 450. So that's set right. So that resonant point really is where it appears to be. 50,000 miles off. Now, maybe the scope is influencing this. This piece of equipment hooked up. If I change the input impedance on the scope, so I'm moving the times 10 switch on the scope lead, and I'm moving it into the times 1 position. Yeah, quite a signal coming on this guy. Still, the resonant point remains way out here. Again, if I increase the impedance, the resonant point, so I'm reducing the influence on the coil I'm measuring. The resonant point, I think it's way over here somewhere. You just see it starting to widen out there. Okay, now I'm going to push the capacitor into contact here. That's interesting. Okay, so I'm gonna put the capacitor back into contact. Yeah, when I say that's interesting, it really means I haven't got a clue why that happened. Okay, so so this is now an original arrangement, if you like. The influence of this has essentially disappeared. Wow, did you see that? Now that was perfect. That's exactly what you want. So I think anyway, this is what's in my head. This is the secondary coil, the one I'm feeding right now. See the resonant point moving around? And this is the primary sitting there, and when the two of them line up, ooh, yeah, look at that. You get nice. You get that. Only that is supposed to be here. So that is occurring at roughly 400. You see, 450, 300 to 375 or even lower with the capacitor. When I take off the capacitor, you see look at everything just goes away. What is that going on? Now, if I stuck a proper size, this is a 47 by measurement. I just take a proper 56 proper. Okay, let me just put my hand in front of the camera here. Come on. All I'm doing is just putting this right in the center. Okay, take it away. I'm going to close in the capacitor here. Right on, exactly the same as the 56. Exactly the same. My 47 measurement was bogus. So at this point, oh yeah, right, I've got this turned way off. So this is not 450, of course, or put this back. This is where we're playing. We're just playing way off course here. Way off course. This is getting weirder and weirder because the range of this coil, as I slide this in and out, is ranging right over there. Like it's ranging over there. It's not ranging, you know, it's not ranging through the 450. It's ranging over here. Like both of these are ranging out. Now I'm really lost. But there's a knock on my door, so hang on a sec here. Okay, so what I did here off camera, didn't do too much. I brought another coil in here, this yellow one. The yellow one is connected to this signal generator here. So that signal generator is just firing this yellow coil, nothing else. Just a couple clip leads, really simple stuff. I tried to move the resonant point here as close to 450, 455 as I could. And in doing that, what I've ended up with this arrangement is this slug all the way to the bottom, and this slug may as well not even be in there. So at this arrangement, with my equipment like this, with this capacitor clip back in, we get to 450 resonance. And this is working, because if I turn this, the resonant point will move around a little bit. It's, you know, 2 points in combination. So what I wanted to do was prove where 450 actually occurs, 455 rather. So that's what this coil is here for, and that's what the other signal generator is for. So I'm going to move, I'm going to manually sweep the other generator through 450, and we'll watch the screen here. Excuse me. And watch for some kind of effect that might indicate when we're passing through the resonant point of the coil. So, okay, I'm starting at 425 kilohertz and heading upwards. So you see something happening already, and then it's gone away. So that's the effect of tuning the second signal generator through. Not quite what you might think. You might think you're going to get some kind of a dot or a point or something showing up, but no. So now I'm maximizing that effect. I'd say it's right here. I would say that the other signal generator is now set to the resonant point of these coils that you see on the scope. And the number is, can you see it over there? You can't. 443. Which in reality is probably 445. That is supposed to be 455. So that actually shows that this is really, it looks like they're almost centered, the scope is centered right on 455. I can just move this over to the center line. We'd be golden. But any attempt to move it, of course one slug is right out too. I mean, this is showing an extreme arrangement here. My question that's just rolling around in my head the whole time is any of this valid? And so let's turn this so you can see what happens. See it? You see the two peaks now are separating, you can see them. And because the throughput of the transformer is disappearing, the signal looks weaker and weaker on the thing. I'll put this back in and slide this back over. We can get it back over. Beautiful, but way off 455 now. So now the slugs are in a more, let's call them, typical position. and this thing is tuning way out here. What has happened here? Both the primary and secondary coils seem happy out here. So I'm going to take off the capacitor. Doink. So the primary no longer has a resonating capacitor with it. That's the secondary being moved around. It's just doing the same thing it was doing before. Roughly the same range. And before, I mean, before I switched the leads around. This one here, we're back to seeing nothing. My head is coming off. I feel kind of bad putting videos like this out, you know, because my practice is to come in here, turn on the cameras, and let her rip. And you know, I really don't know what's going to happen. That should be pretty apparent to those of you who watch a lot of my videos. And I kind of enjoy that a little bit, but it can be frustrating both for me and I'm sure for you too, especially if you think I'm just doing something stupid here, that if I just stopped doing it, everything would be normal. Insufficient capacitance. So I measured that at 47. Now, why would it become insufficient? 47. Make sure I got this as a 27. What's that doing here? 56. This is what's just doing the same thing over, expecting different results. And sometimes I do get different results when I do things over. Okay, so let's put in more capacitance. Well, you know what I can do? I just clip this. That's 50. You put this on. That's 100. Boy, I didn't like that very much, did I? Oh, they've gone way off to the left. But I want it to go to the right. But when I reduced this capacitor, it maybe it flew a mile off to the right. Now I happen to have a 27 here for some unknown reason. Let's use it. That's half the called for capacitance. Okay, that's interesting. Well, we're on the other side of the resonant thing now. I can't get there with the primary. Don't you think this is kind of weird? See if I can get the primary peak to get to where I want it to be. Oh, wrong terminal, that's the problem. Pretty easily. That was pretty easy. Primary slug is way up here though. Let's go with this one now. Can we get there? Well, almost. So what's that telling you? I need to reduce the capacitance on this side also. Well, why would these be looking for reduced capacitance here? is once these regular capacitors are connected, they're 56. This is 27. Yeah, 27. That's a really unexpected situation here. So let's see if I got this clear in my head, because I don't think I do. The capacitor that's in there is less than 56, and the resonant point is moved off to the left, or gone down frequency. But yet, so when I reattach it, the resonant point comes close, but still to the left. But I put in a smaller capacitor, and you know what? I can't. This just doesn't add up. This is just not adding up. I'm sure it's just my head. I'm sure it's just my head. Look at that. I mean, it's right there. Well, I think the name of the game is, I can't do anything about these coils. So we put this guy back in, and I do what I said I think at the end of the last video. Remove these two capacitors, put the whole thing back in, and then progressively apply capacitance to the terminals from inside the chassis until this thing hits the mark. I think that's the only way I can go. What about the can? I already tried this, didn't I? Didn't I try sliding the can on to see if this is this is the missing link? Let's get this thing resonating here. That was. I'm all lost here. Get it. I'm going to use this clip lead. This is just to get a bigger display on the scope, basically. There. Okay, let's line them up a little bit. So that's what's possible on the second line over. Okay, this comes out, can goes on. This is not easily done. This has to be through there. So there's a second little sheet of aluminum up in the top there, and it looks like they made the two of them come together with these little notchy things here. They somehow punched it to, oh, for crying out loud. What am I showing this to the camera? You're over here. Oh, man, alive. Don't break this thing now. Oh, how do you like that? So I take back, these little tabs here are the holders of the spring. God knows what I did with the spring wire. And that's what's going to hold this and make the threads activate. So I really don't need this thready sort of hole here. Okay, we're in business. You ready now? We're in some kind of business. Watching the scope. Oh. That's right, the slug is out. The slug is out. Let's slug it out. Okay, in you go. Slug in. There, slug is going in. Hey, where'd everything go? Come on, don't do this. Slug is just, well, we got a whole different situation now. Okay, so oh my gosh. So maybe I should really cut those capacitors out, put this thing back together can-wise, fiddle with additional capacitors with it out on my bench, get this thing within range, tuning within range, to stick it back in the radio. We've just lost virtually everything. Look, I can just, this is, you know what, this is now behaving the way it did before. I'm about to drop the slug right into the can, and resonance is starting to show up. God help me turn this here thing. Holy smokes. I mean, ultimately, what am I going to do about this? So that's, oh, that's interesting. I thought that would be, what? Okay, so the one I'm moving is the primary side. It's almost disappeared. No, don't do that. Turn this in too far. This is the part where you damage one of the coil wires now. A little spring there. Spring wire. This doesn't do well when the slug is not in the thing. Oh boy. Many lessons learned. Using my X-ray vision now. No, I'm cheating. There we go. I got it. Okay, I got it. I heard a little click in there. Is that clip lead coming off? Well, I got it together here. Not me personally, just this transformer. What do we got on the scope? We got next to nothing showing up there. Oh my gosh, what was that? Okay, don't know what that was. That's better with my thumb on it. How about that? Nobody's home. Once I put this can on, everybody's gone away. How can this possibly be? So primary adjustment, it's raising the output, it's raising this level. I think this is moving. Yeah. Okay, so the slug is almost out of the coil now. I can just tell from the amount. She's out and going beyond. Oh, I can get. So I think that's the limit there. And the other coil. That's really wonderful. Really wonderful. We'll check and see if that's 455 by doing the interference thing with the other signal generator. Which is, of course, the coil sitting over here now. Yeah, I'm not sure. Not sure one is going to influence the other. Like this. I have the feeling this isn't going to do anything. Okay, another approach. We'll stop the sweep and we'll adjust the sweep generator. First I will set this. I'll use the scope to set this right on the center line. Okay. Right there. Stop the sweep. Now I think we're just going to be looking at this point getting bigger and smaller. That's all we're going to see here as I move the start frequency up. There it is right there. So okay, I'm going to put it on max and max it. Right there, and the frequency is 437. 437. And 450 looks like this. 455 looks like that. Okay, let's put this on 455. This is kind of a classic way of doing these. Not quite. You use a meter, not the oscilloscope. 455. Did anything just jump like crazy there? Yeah. It's okay. It's because I'm tuning this up to the wrong spot. I'm saying 455 and doing something totally different here. 4. That's a sign I've been in here too long. 455. That's got to be good enough. Good enough. 455. Now, can we tune this and give us a nice big thing there? Come on, give us a nice big thing. The answer is yes. Oh, guess what? I've hit the limit. That's the stop. And I think we're right on the money, right at the stop. Now the other end. It's also at its limit. No, I'm pushing it past its limit now. Bottom slug is as low as it'll go, upper slug as high as it'll go, and we're at 455. Holy crap. Man. What have I proven here? I don't know if I've proven a darn thing through all this. Well, I have to ponder. I have to ponder here. So I think I'm right back to where I was at the end of the last video. Clip out the capacitors, put it back together, stick it back in the radio, mess around with capacitance until this thing resonates where I want it to. It looks like it can get in the range if I put the right amount of capacitance. Oddly enough, it looks like reduced capacitance is what it's looking for, but it could be I put it back in the radio, there's enough stray capacitance and other things going on in the circuits that it all works out. I can put this thing back in and find out everything works perfectly and never know what the heck I was doing the last hour and a half. Wouldn't be the first time. The last few hours, actually. Wouldn't be the first time I've gone off on wild goose chases. Would not be the first time. So unfortunately, this is it. This is where I got to. Where did I get to? Pretty much the same place I was. So I went around in a big circle here. So, well, I hope you're finding this interesting. But I have to work my way through it. There's just no two ways around it. Whatever it is, if it's a hole in my head that's causing this, then I've got to fill that hole. I need to fill it with coffee. Okay, thanks a lot for watching, and I'm going to enjoy the day. Rain is coming later today, so I'm going to get out there now and enjoy it. See ya.